Hey there, friends. How are you? So, in our last video, we introduced interest rates and we talked about how interest rates are the price of money. And we talked about simple and then compound interest. And that's a really powerful idea. At the end, we were able to think through not just interest rates, but the idea of interest rates and time. And we start thinking about the role of time on our system. In this video, we're going to learn a new concept. It's related to interest rates and it ties into it, but it's a new concept and it's called the time value of money. Okay? It's called the time value of money. So what I want to do is I'm going to open up. If you were to go to DuckDuckGo or any other search engine and you do a search under financial calculator, you'll see a bunch. These top two are really good. So go ahead and open one up, calculator.net or financial or fncalculator.com. They're both good. I've opened up both. If you open up financial calculator, I'm sorry, calculator.net, you'll get this screen here. And if you open up FN Calculator, you'll get this one here. They're both excellent. They both get the job done. Pick which one that you feel comfortable with. Okay. I'm going to leave it here for now. And then what I want to do is I want to get to our um, notepad so we can start taking some notes, and we'll be going back and forth between these two things. So we left off last time talking about the idea of time value of money. Sorry, about interest and interest rates. And at this point now, let me make sure. There we go. At this point now, we want to evolve that. So let's get into the idea of the time value of money. We hinted at it because when we did this little exercise on compound interest, we learned that a dollar today can grow to more than a dollar in the future. This is a really important idea. This, in fact, is sort of the basis for the time value of money and the idea of time being a powerful force in personal finance. We say, let me get rid of this. We say that a dollar today is worth more than a dollar in the future. It's another way to say it. $1 today is worth more than a dollar in the future. I mean, think about it. Suppose that I bought something from you. It was $100, so I buy the product and I say, hey, listen, you can either get the $100 today or I'll give you $100 next year. Which one are you going to take? It should be obvious that you're going to want the $100 today. Why? Well, we learned that if you have $100 today, if you have a dollar today, you can invest it, you can save it, you can grow it. And we learned that with compound interest, even a dollar today can grow quite a bit over time. So we put all this together and we get a really big idea. $1 today is always going to be worth more than a dollar that you're going to receive in the future. Okay? We introduce the element of time into our discussion. To do this, we're going to introduce a few different ideas, a few different terms, okay? In fact, there's 5 or so big terms when it comes to the time value of money. Term number 1 is the future value, which we call FV. The future value is, you can be thinking the future value in a couple of ways. The future value of money is how much you expect to get in the future. So if I say something, hey, I want to borrow some money from you today, and I'll pay you back $3,000 in 5 years because you're going to get that 3,000 in the future. That's the future value. So the future value is how much you expect to receive at some point in the future. Another way to think about the future value, it's how much a certain amount of money today will be worth in the future. Okay, so the future value is either how much you'll get at some point in the future, or it's how much money today can grow to in the future. The second big idea is the present value of money, what we call the PV. And the present value of money is seen in a couple different ways. The simplest way, the present value of money is what you actually have right now. Like if you have cash in hand right now, that's in the present, that's the present value. So that's pretty simple. There is a slightly different way to think about it. The present value can also be seen as if you know that you're going to have money in the future, what's it worth today? That's confusing. Let's say it again. Let's say that I tell you, hey, I owe you $3,000 and I have to pay you in 10 years. And you say, well, Eric, I don't want the 3,000 in 10 years. I want it now. The present value today is how much $3,000 10 years from now is worth today. Seen another way, the present value today would be how much money you need today to grow that money to the 3,000 in the future. This is a lot of jargon, and I want you to get to be flexible with it and build some intuition and some awareness. So we're not going to belabor the point, but just know present value is what you have in hand today, and future value is what you're going to have in the future. But the beauty of finance is we can go forwards and backwards in time. We can go from the present value to the future value. And we call this compounding, which should make sense from compound interest. But we can also go backwards in time. Suppose that you know the future value. You can pull the future value back to the present, and we call moving money in this direction discounting. So when you hear the terms compounding or discounting, it's just talking about the movement of money through time. The movement from the present to the future is called compounding. If you have a future value and you pull it back to today, that's called discounting. Okay, and they're both really important. So future value, present value. The other components in time value of money include the interest rate, which we call I, or sometimes IY, interest per year. The number of periods that we're talking about, in other words, the time, which we call N for number of periods, and then the payment. Let's talk briefly about payment because payment's interesting. When we talk about payment, we're using the term in finance a little bit different than in everyday life. In everyday life, you just think of a payment as you're sending money to somebody else. Money's flowing out. It's not quite what we mean here. In finance, a payment, which we call PMT, this refers to a series of equal cash flows. Payment, or PMT, just refers to a series of equal cash flows. That's it. Those cash flows can be flowing into you and be received by you. So if, for example, you're retired and you have a retirement account and you're going to receive $1,000 a month, as long as the cash flows are equal, that's a payment. It's coming into you. If you buy a new car and you have to spend $500 a month for your car payment, that's a payment out. It's a cash flow, it's equal amounts, and it's going out. So the key to understand payments is that payments can come in to you or flow out from you. What we do to differentiate this in finance, any money that flows into you, we indicate with a positive sign. And any money that flows out from you, we indicate with a negative sign. Okay? So when you see a positive sign or a negative sign on these things that we're going to do right now, it just is telling you, is the money flowing out from you or into you? Okay? One final term that you want to know is the term annuity. Annuity refers to a situation where there's payments being made. Okay, so when you hear the term annuity, know that annuity goes hand in hand with payments because an annuity is just a setup where there's a PMT coming in or going out over time. Okay, so those are some basics. I think the best way to do this, let's just jump into it. Let's talk first about future value. And let's do some simple calculations. Let's talk about future value. And let's start off with a simple idea, a definition. Okay. Future value asks, how much will a lump sum of money that you have today be worth at some point in the future? You have a certain amount of money today. You invest that money or you set it aside for a certain amount of time at a certain interest rate. How much money will it be worth in the future? Okay. To visualize this, we can think we're doing this. We're doing the present value, which we know, and we're trying to figure out the future value, which we don't know, when the money is growing for a certain number of periods at a certain interest rate. Okay. So let's just do a simple example. Let's say that you are 22 years old. So you're 22 years old. You just got your first job. Congratulations, go you. And you received a $5,000 signing bonus. Now, part of you wants to go to Las Vegas and spend that money, but the other part of you says, nope, opportunity cost. I'm going to use this money for my wealth building system. So you take that money, that $5,000, and you put it into an investment account. And you earn 5% per year. How much money will that $5,000 grow to in 40 years? In other words, we're asking this. If you have $5,000 today, how much money will it become if it can grow at 5% interest for 40 years? Now, if you think about it, this is a compounding problem. And you could do 5,000 times 5% and then get that new number and plug it in and do that 40 times. It's kind of rough and you don't want to do that. You can also apply a shortcut formula. So here's the shortcut formula. Future value equals present value multiplied by 1 plus the interest rate raised to the exponent of n. So you could theoretically say that the future value is equal to the $5,000 that you have multiplied by 1 plus the interest rate raised to the n of 40, or $5,000 times 1.05 raised to the 40. And you can do that math, and that answer will tell you what that 5,000 grows to. But to me, you don't have to do that math. I mean, you can do it if you want, but we have a simpler tool. We got a great tool, time value calculator. So here's what we're going to do. We're going to go away from the formulas and we're going to plug it into the calculator. I want you, though, to always be organized. So anytime we're going to do a time value problem, we're going to use a cheat sheet. We're going to use an organizer. So we're going to say here, PV, FV, NI, PMT. These are our 5 variables. Now check this out. On any time value problem, there's 5 variables at play. 5 variables. I'm going to give you, or you're going to be able to figure out 4 of them. Your job in every time value problem is to just find the missing variable. In other words, I like to think of a time value problem as a scavenger hunt. There's 5 total variables. I'm going to give you, and you can figure out 4. You solve for the missing one. So in this case right here, the present value is going to be $5,000. But since we're going to put it into the account, it's going out. That's going to be negative 5,000. We're going to invest this money for 40 years. So N is 40. We're going to have an interest rate of 5%. So I is 5. PMT, there's no PMT here. We put a lump sum in at the beginning. PMT is going to be 0. There would only be a PMT entry if we put money in over time in an equal series of equal cash flows. These are the 4 that we're given. And we're solving for the future value. It's a scavenger hunt. So let's now go to a financial calculator. And let's figure out how to do it. I actually want to go to this one first because I want to show you something here. We see up here the calculator itself. Notice that there are 5 variables here. FV, PMT, I, N, and PV. This calculator has the exact 5 variables that we've talked about. Here's the key, scavenger hunt. Whichever variable you're solving for, you click. So if we were solving for present value, we're not, we would click PV. If we were solving for interest, we click I. You're gonna click the variable that you're solving for. That's your scavenger hunt is all about. So in this problem, the one we're solving for is future value. Notice that when I click future value goes gray. The other 4 variables that we were given are blue. And notice furthermore that there's blank spaces here for all those variables. So we just plug in. We know that N was 40. We know that the interest rate was 5% per year. We know the present value we're putting out, so it's negative 5,000, and we know that there's no PMT. So we've got it plugged in. No need for complex math, no need for hard formulas. We have a need for some intuition. We got to get comfortable with the jargon, but you practice and you get it. And look what we're doing. We're telling the computer, hey, software, please tell me if I put $5,000 away right now at 5% interest for 40 years, no PMT, what will it be worth? Hit calculate, and there's your answer. $35,199.94. In other words, you can grow through the magic of compound interest $5,000 into $35,200. That's the power of compound interest. That's the power of growth. What this calculator does is it gives us a way to solve problems easily. Excellent, excellent, excellent. Let's practice another one. Now let's say that you put $10,000 into an account. So you put $10,000 into an account. It's earning 7% per year. Here's a question. How long will it take you to double your money? Interesting. In the first problem, we just want to know what it was going to grow to. Now we want to know how long it'll take to double the money. Sounds confusing, but it's solvable. Let's get our 5 variables down. We have $10,000 right now. So we're going to put that into an account, let's say. So present value is going to be negative 10,000. Okay. In case you're confused, the 10,000 was straightforward. That's the amount. It's negative because to double your money, you're assuming that you're going to put the money out into an investment. And when money goes out, signs are negative. To double your money, we have to go from 10,000 to 20,000. I didn't give it to you, but you can sort of deduce it. Notice furthermore that since the money's coming back into you, the 20,000 is positive. We said that you're going to grow your money at 7%. That's your interest rate. That's a given. Since I gave you no indication of PMT, that's a 0. And now we're solving for n, and that makes sense. N is the missing variable, and we're asking how long will it take? Well, that's a time period. So we have that. Let's go back in. Let's plug it in. We're solving for n. So we click n. Notice now that n is gray and the other 4 variables, the ones that I gave you, are blue. We're going to plug in the ones that you have and go on the scavenger hunt. The interest is 7. The present value is 10,000. There's no PMT because I said nothing about ongoing flows of money, so that's a 0. And the future value, well, I didn't tell you directly, you can say, well, I started with 10, I want to double it, so it's got to be 20. And here we are. We're asking the computer, we're saying to the software, hey, software, we're on a scavenger hunt. If I have $10,000 now and I want to grow to 20 and I can earn 7%, how long will it take me? We click calculate, and n is 10.245 years. 10.245 years. So n is going to equal 10.245. Because we default to years, it's years. So now you just learned. I can figure out how much money will grow to, or I can figure out how long it will take to grow to a certain amount. It's all about the scavenger hunt. Okay? So that right there are some pretty easy future value problems. Okay? Future value problems. Now, let's get a little bit trickier and let's go from these simple future value problems to the future value of an annuity. And remember, with an annuity, we're not putting a lump sum in at the beginning. We're putting little amounts in through the life of the investment. Okay. Whenever you hear annuity, let's remember we're talking about PMTs. So there's going to be some sort of equal series of cash flow. So you want to get your head ready for that. Okay. Let's do a example here. At age 22, so starting at age 22, you decide to open a Roth IRA. Good for you. You're going to open up an investing account, a Roth IRA for your retirement. Excellent move. And you're going to start when you're young because time's going to work for you. You know this part of the system now. You open a Roth IRA and you decide that you're going to put $6,000 per year into your account. So you say at 22, all right, I got a job, I've got some income, I'm going to start my IRA and I'm going to commit to putting $6,000 a year into it. You expect to earn an average of 7% return over your investing life. And let's say that you want to retire at age 67, so you're going to be investing for 45 years. Question is, how much money will you have? Well, a bit trickier, but let's get going here. Present value, future value, NI, and PMT. It's a scavenger hunt. So let's figure out what we've been given. Well, you know that if you're 22 right now and you're going to retire at 67, your N is 45. So we got an N. And you know you're going to earn 7%, so we got an I. Now, PV is a tricky one here, but think about it. You're not putting a lump sum in. You're not putting a big chunk of money for one time in. So PV is going to be 0. Instead, because you're saying, but Eric, we're putting money in. Yeah, you are, but you're not putting in a one-time lump sum. A PV means a one-time lump sum. You're putting in $6,000 every year. Much different. $6,000 every year. So that's a PMT. And because you're paying it out, you're sending it out from you to go into your account, it's going to be negative $6,000. Therefore, what we're solving for is PV. If you wanted to think about this from a visual perspective, you can say something like this. You can say, well, today is year 0, and then year 1, and then year 2, et cetera, et cetera. You're saying that you're going to put $6,000 in this year and next year and the following year and all these years. What we're trying to see is what each of these contributions will grow toward. If you were a glutton for punishment, you could actually do 45 simple calculations and add them up. But I don't want you to do that because you don't have to, because we know how we can solve this with a calculator. So let's go back to our calculator. Let's clear it just to make some sense out of this. We know we're solving for FV. So we're going to click FV, and FV goes gray. And now FV goes gray. And now the 4 in blue, PMT, interest, N, and present value, we already have those. Plug in what we know. N is going to be 45. The interest rate is going to be 7%. The present value is 0. We don't have anything in there right now. But we're going to be contributing $6,000 a year. And because that money's going out, -6. We double check our entries and we're asking the software, hey, software, please tell me if I put $6,000 a year into an account for 45 years and that account pays and grows at 7%, what will I have? Hit calculate, and there you go. Your future value is going to be $1,714,496. And congratulations, you're a millionaire, and it only cost you $500 a month. That's $250 per paycheck. That's about $18, $19 per day. A little bit of money set aside, the power of time and compound interest, and you're set. Okay? And that's how it works there. I do want to share with you now one last problem, and then we'll end this video, and then we'll wrap up time value with the third separate video just to keep them short. I want to share with you one little complexity now. Look at this problem that we just did. We said that you're going to contribute $6,000 here once per year. Yeah, that's what we said. We said that you're going to put $6,000 in once per year. What if instead of putting in $6,000 once per year, you wanted to put in $500 per month? So it's the same sort of problem, but now it's not going to be $6,000 a year. It's going to be $500 per month. You're still putting in 6,000, but it's 500 per month, not 6,000 one time a year. You're still going to grow at 7%. But to solve this problem, we have to make some adjustments. Remember I said earlier that all the time value questions default to a period of a year. If you're talking about a year in your problem, you're fine, leave it alone. But anytime you're talking about a period other than a year, you have to adjust. And specifically, since right now we're talking about going from a yearly contribution to a monthly contribution, we have to adjust n by multiplying by 12. In other words, we are going to contribute for 45. So we're thinking about n. We are going to contribute for 45 years, but since we're doing it monthly and there's 12 months a year, our n is going to be 540. Now, if we're going to inflate the n and adjust that up, then we have to deflate the I, because remember, the I was the APR and the A was annual. So to get the I, we have to take the APR and divide it by 12. If we're going from yearly to monthly, we have to increase the N to account for the number of months, but we have to deflate and decrease the I to account for the fact that they're going from annual to monthly. So this would be equal to 7% divided by 12, which would be 0.583%. You can think of this as the monthly interest rate, and this is the number of months. Okay? If we do that, we can solve pretty easy. PV, FV, N, I, and PMT. Our PMT is now going to be $500 going out. Our I is going to be 0.583. Our N is going to be 540. We still don't have anything here, and we're still solving for our future value. How do we do it? Well, we just make the adjustments and we keep the calculator the same. We're going to change our N from 45 to 540. That takes us up by a factor of 12. We're going to change our I from 7 to 0.583. That takes us down by a factor of 12. And since it's monthly, we're sending in 500. We calculate it, and we see that at the end, we're going to have $1,893,836. And that's how we do that, okay? Let's get out of this. Let's talk about this real fast, and then we can wrap this up. Notice you're still putting in the same amount of money. So you might be asking, well, Eric, then if you're putting in the same amount of money, why are we slightly bigger here than we were here? And the answer is because you were putting in money every month, you were getting a little bit of interest every month. You were getting a little bit of growth every month. When we put the money in at the end of the year, we got interest, but it started at the end of the year. when you put money in every month and you start early, we're starting early, we're maximizing our N, we're making that loop bigger and bigger. The difference between this one and this one represents the extra interest that you accrued over time by starting a little bit earlier and putting a little bit in. Okay? And that, my friends, is the time value of money for future value. I want to show you one last thing. I mentioned before that we have two calculators. I like this one. I've used it often. I still use it. But when you have to do adjustments, you have to kind of go in and tweak this. Let me show you the time value calculator at www.fncalculator.com. Check this one out. Here, we're going to use the same numbers as last time. The present value is 0. The payments are going to be negative 500. The annual rate is 7. You say, but Eric, wait a minute. We have to adjust it. I know. Hold on. The periods are still going to be 540. You say, Eric, you can't solve this yet because you inflated the N for the months, but you did not yet deflate the interest rates. This is why this calculator is sometimes more handy, because look right here. We have the compounding window. We can set it for annual or semi-annual or quarterly. Since we're making our payment monthly, we click monthly here. And now we're telling the software, we're saying, hey, we're putting in 500 a month for 540 months. We're going to get 7% per year, but we don't need to do the division because the software says 7% per year and it's monthly, we're set. You leave the one that you're solving for blank, you click FV, and there you go. 1,896,297. Okay? That's a little bit of a discrepancy. It's probably a bit of a rounding thing. Let's see if it's this. Nope. So it's a little bit of a rounding thing. These things happen, but there you go. So now we have two options. We have the finance calculator here, where you're going to manually adjust the interest rate and the N, or we have this calculator where you just, let's get rid of this, where you leave the interest rate alone, and then you just account for the monthly thing, solve it, 1,896,297. And again, when you do these kinds of problems, there'll be some rounding errors based on how the software pushes it through, but there you go, okay? And that's time value of money overview and time value of money present value. In our next video, we will do the future value, and then we'll be, sorry, this was the future value. Forgive me. We'll do present value next.